So let's keep going. So now we're going to talk about types of errors. So the main types of errors are type 1 and type 2 errors. So as you see here, I have a table. So let's talk about our decisions. So in hypothesis testing, everything is based on the null. Either your null is true or your null is false. So we don't really talk about the alternative in that way, but we base everything on the null. So let's say your decision was that your null is true. And in reality, your null is true. So if your null is true, but you reject it, you make a type 1 error. So again, if your null is true, but you say it's false, that's a type 1 error. And if you say your null is true and you didn't reject your null, that was the correct thing to do. So what if you said your null is false and in reality it really is false? You made a correct decision. But say you said the null is false, but in reality it's true, that's a type 2 error. So remember, type 1 is where the null was true, but you said it was false. And a type 2 error was where the null was false, but you said it was true. So each of the errors occurs with a particular probability. We use the Greek letters of alpha and beta to represent the probability. Alpha is the probability of a type 1 error. So it's the probability of rejecting the null hypothesis when the null is really true. Your beta is the probability of a type 2 error. That's the probability of not rejecting the null hypothesis when the null is really false. You want your alpha and beta to be as small as possible because they're the probabilities you'll have errors. They're always rarely zero. You'll always have some kind of error. So the power of the test is 1 minus beta. Ideally, we want a high power so it can come as close to 1 as possible so we don't have so many errors. A way that you can increase the power of a test is increasing your sample size. So here's an example of one. Suppose the null hypothesis is Frank's rock climbing equipment is safe. So the type 1 error is Frank thinks his rock climbing equipment may not be safe when in fact it really is. The type 2 error is when Frank thinks his rock climbing equipment is safe when in fact it's not safe. So alpha is the probability that Frank thinks his rock climbing equipment may not be safe when it really is safe. Again, that's the type 1 error. And beta is the probability that Frank thinks his rock climbing equipment may be safe when it's not safe. And again, that's your type 2 error. Notice that in this case, the error with the greatest consequence is type 2, because if you think your equipment is safe and it's really not, you can get in trouble. So let's talk about the 3 types of distribution needed for hypothesis testing. So when we write our distributions, if you're testing a single population mean, the distribution for the test for the mean is x bar is equivalent to n, and in parentheses, the mean, comma, standard deviation times x with the square root of n, or t with the degrees of freedom. And I know it doesn't make a lot of sense right now, but we're getting there. And then if you're testing a single proportion, then the distribution of the test for proportion is p with a comma up top, tilde n, where in parentheses is p, and then it's the square root of that. So there's 3 different types. Particular distributions are associated with hypothesis testing. Perform tests on a population mean, you're going to use either a normal distribution or a student t-distribution. A normal distribution is known when the population standard deviation is known. This is also known as a z-test. Remember z-score back from before? This is what we're doing. A student t-distribution is when the population standard deviation isn't known. So again, normal distribution is when you know your population standard deviation. A student t-distribution is when you don't know your population standard deviation. So When you know your population standard deviation, it's called a z-test. So you're going to use your population mean, which is the mean that you use in the hypotheses. You never use your sample mean in the hypotheses. Then you also have a sample mean. You have a sample size, and it has to be equal to or greater than 30 to use this test. The population standard deviation has to be given, and you need to have your level of significance or a level of confidence. To use the student t-distribution, it's called a t-test. A simple random sample has to be used. The population standard deviation is not known. The sample size is 30 or greater or normally distributed. Note that if a sample size is sufficiently large, a t-test will work even if the population is not normal. But we're talking massive sample sizes, like 2 to 3 to 4,000 or greater. All right, hypothesis testing for a single population proportion. You have to take a simple random sample from the population. You have to meet the following conditions, which is a binomial distribution. Now, a binomial distribution is just, it could be like you toss a coin. Heads is one, tails is the other. Because when you toss a coin, you either get heads or tails. There's two scenarios that can happen. It's a tail or a head. So that's binomial. You have two things that it can come out to. Bi means two. So nomial means number. So two numbers. So there are a certain number of n of the independent trials, and the outcome of any trial are success or failure. And each trial has the same probability of success. The shape of a binomial distribution needs to be similar to the shape of a normal distribution, and we're talking that curve. So to ensure this, the quantities NP and NQ must be greater than 5, with NP greater than 5 or NQ greater than 5. And the P here is talking about, you can give it like with the heads or tails. I'll say I want to toss a coin 10 times, and heads is P and tails is Q. So N is 10 because I tossed the coin 10 times. Say I tossed 4 heads. So P would be 4 because that's the number of time I tossed heads. And Q would be 6 because that's the number of time I've got tails. So remember, Q equals 1 minus P, or Q equals the non-success.